In this video, we're going to look at solving simultaneous equations when one is linear and one is non-linear. Let's start off with the concept of linear and non-linear. If I write an equation y is equal to x plus 2, this is a linear equation. It will give us a straight line. We can see the highest power of y is 1, the highest power of x is 1, and there's no product, no multiple of x and y. So this just gives us a straight line, and we say that that's a linear equation. An example of a non-linear equation could be a quadratic. So y is equal to x squared plus 10x minus 12. That is a non-linear equation as we have a squared term. Another example of a non-linear equation might be the equation of a circle. X squared plus y squared is equal to 100 is the equation of a circle, centre 0, 0 and a radius of 10. Quite clearly that isn't a linear equation. Another example of a non-linear might be y is equal to 2 over x. We see that this gives us a reciprocal function, and this again is non-linear. So what we're going to have is one that's linear and then one that's non-linear. It could be a quadratic or it could be a circle. It might even be a reciprocal. Less likely so, but we're going to look at these anyway. These are the main two that we need to focus on. So let's have a look at what's going on. What I've got here is a parabola and a straight line. We can see at the moment the straight line, the linear graph, cuts this point here and this point here. So it passes through the quadratic equation twice. So we have two solutions to this particular simultaneous equations, or the set of simultaneous equations. If I change this though and look at the c value, so if we just go ahead and change this over, I look at the c value of my straight line, that is the y-intercept, there'll come a point where we've got no solutions. So there's no points of intersection, or at least we can say there are no real solutions to those simultaneous equations. We can see we've got two here and none just here. We might have one, so if I just change this now, if I have a tangent, so this straight line here, and I'll just change this, we can move this up, let's move that, there we go, there. We can see we've got one point here where it touches, so we'd have a repeated solution. So that gives us now a parabola and a straight line. So we can see that we've either got 2 points of intersection, one or none. Let's now swap the parabola for a circle. So if I take the parabola off, we've now got a circle. So if we look at the equation of this circle, and I'm just going to change now this, let's go ahead and do that. This is x squared plus y squared is equal to 2 squared, which would give us 4. So x squared plus y squared is equal to 4. So again, if we look what we could have with our straight line and our circle, we could have now a tangent, which would be 1 point. So we'd have one x coordinate, one y coordinate. If I change this over now and change the gradient, we can see from here that we could have 2 points of intersection. We might also have no points of intersection, so we wouldn't be able to solve the quadratic that we broke this down into. So that gives us a circle and a line. Let's now look at the scenario when we have a reciprocal. This is less likely to occur, but it's interesting nonetheless. So we can see we've got these 2 points of intersection. So if I change the gradient, we can see we've got the 2. The only time when we're not going to have those is when we have just there. Let's go ahead and see if I can't actually do it. But if we have the lines x is equal to 0 and y is equal to 0, as they're the asymptotes of the graph. But as you can see from here, we're going to go ahead and we're going to have these 2 points of intersection. So there we go, that's the whole concept of this. So rather than just plugging in numbers, I think it's interesting to look what's going on. So let's start with an example and we'll go ahead and solve it. Let's say we have y is equal to x plus 2, which is a linear equation like this one here. And then let's take y is equal to x squared minus 4. So this is a straight line and this is a parabola. If I drew a quick sketch, and remember your sketches don't have to be massively accurate, we've got now a standard quadratic curve. The quadratic curve has been moved down by 4 units. It will look something like that. Okay, so that's what we have. We also have a straight line with a gradient of 1 and a y-intercept of positive 2. So that's going to look something, give or take, like so. So what we're going to have then is this straight line and the quadratic equation. From this we can see that there are going to be 2 solutions. We're going to have one here and we're going to have one here. We can use algebraic techniques to find these. So I'm going to have an x, and I'll just put it here, x1, y1, and we're going to have x2, y2. So I'm just going to find an x value for both and then find the y value. Often students forget that they solve for one unknown and don't go ahead and do the other. So let's go ahead and label these equations up. The way in which you deal with them is entirely up to you. What I'm going to do is say that if y is equal to x plus 2 and y is equal to x squared minus 4, we can say that x squared minus 4 will be equal to x plus 2. By doing this, I've eliminated y. So when we were looking at linear simultaneous equations, we went ahead and eliminated one of the unknowns, or one of the variables. An alternative is you could say, well, I'm going to do now equation 2 minus equation 1. You will get the same result. You'll end up now eliminating y. I'm going to rearrange this as a quadratic in x, solve for x, and then substitute back in to the linear, the easier equation, to find y. So subtracting x from both sides, x squared minus x. Then I'm going to have minus 4, and subtracting 2 from both sides, we're going to have now x squared minus x minus 6 is equal to 0. This factors, so we can factor the quadratic. We're going to have x minus 3 multiplied by x plus 2 is equal to 0. So we can see that x would be equal to 3, or x would be equal to negative 2. So these are my 2 solutions for x. I now need to find the solutions for y. All we've said is essentially, and my graph is pretty accurate here, we can say that x2 is going to be negative 2, and we've got x1 to be equal to positive 3. We need to find y1 and y2. So all I'm going to write here now is when, and just jotting this down, when x is equal to 3, we can say using the linear equation, and this is equation 1, y is going to be equal to 3 plus 2. So I'm simply substituting this into the easier of the 2 equations. So y is going to be equal to 5. So when x is 3, y is equal to 5, and that gives us the coordinates just there, 3, 5. I'm now going to say when x is equal to negative 2, so when x is equal to negative 2, y is going to be equal to negative 2 plus 2, and then that'll give us that y is equal to 0. So we have this point just here. So if you're asked for the coordinates are negative 2, 0, and we have now the 3, 5. So 2 points of intersection, and they've turned out to be nice integer values, as we can simply substitute them in to this, find that they give us some nice values, plug it back in. Always go with the easier equation when you're trying to find y. So all I've done, instead of putting them back into the quadratic, I've put them into the linear. So I've solved for x and then gone ahead and solved for y. Okay, let's just look at what I said about 2 minus 1 here. So if I write this now, and I'll write that y is equal to x squared minus 4, that's equation 2. And then y is equal to x plus 2. If I subtract downwards, what we're going to have here is the following. Y subtract y gives me 0. We're going to have x squared, then we're going to have minus 4, then we're going to have now minus x and minus 2. So that's another way of looking at it. Alternatively, you can just say y is equal to y and solve. So we solved in x, we found the 2 x values, and then we substitute into the linear to find y. Okay, let's have a go at another one. So let's say we've got now x squared, and we'll go for minus y plus 3 is equal to 0. And we'll have, let's go for x minus y plus 5 is equal to 0. I'll call this equation 1, and I'll call this equation 2. At this stage, you can do equation 1 minus equation 2. I would prefer to rewrite these, and I'd prefer to write that x squared plus 3 is equal to, and adding y to both sides, y. With this one, I'd like to say that x plus 5 and adding y to both sides is equal to y. So now we have y is equal to x squared plus 3 and y is equal to x plus 5. Therefore, what I can say from here now is that x squared plus 3 will be equal to x plus 5. You certainly don't need to, but it is an option for you. You can simply subtract downwards here. Okay, so what we're going to have, our quadratic on the left hand side, we're going to set this to ax squared plus bx plus c is equal to 0. So x squared minus x. I'm going to now subtract 5 from both sides, so that will be x squared minus x minus 2 is equal to 0. We can factor this. We're going to have x minus 2, and then we're going to have x plus 1, and that will be equal to 0. So x will be equal to positive 2, or x will be equal to negative 1. Both of these examples have given us integer values. That won't always be the case. We're not always going to get nice numbers. It might turn out to be decimals, and use your calculator to work those out. So nice and straightforward here. So all I'm going to do now is take my x values and substitute in. So I'm going to write here now when x is equal to 2, y is going to be equal to, and I'm simply going to use this equation right here. I'm going to use the linear equation, equation 2. You can put it in here, I just think it's probably easier putting it in here. So y is going to be equal to 2 plus 5, so y is going to be equal to 7. So if we wanted the coordinates, we could say the coordinates of a point of intersection of a parabola and a straight line, we're going to have 2, 7. If we go for the next one, when x is equal to negative 1, so when x is equal to negative 1, y is going to be equal to negative 1 plus 5, and that's going to give us that y is equal to 4. So we've got the coordinates now, negative 1, 4. And if we think about this, this is just now a straight line and a parabola again. So a quick sketch up, let's go ahead and do that. We've got a parabola, x squared plus 3, so that is the standard x squared curve, just translated now by 3 units. Looks something like that. And then we've got now the line y is equal to x plus 5, which is going to look something, let's put this on, something like that. Okay, so that's what we have. So we've got these points of intersection, and we've got now negative 1. Let's put that one on. So this corresponds to the negative 1, 4, just here. So that's negative 1, 4. And this one right here is going to be the 2, 7. So 2 nice integer values, whole numbers, and we've solved. Okay, let's look at another question. Let's go for, this time, the equation of a circle. So what we'll do, we'll have one linear. So let's have y is equal to x plus 1. So again, straight line, y is equal to x plus 1. And then what we'll have is x squared plus y squared is equal to 25. I'll call this one now equation 1, and I'll call this one equation 2. What I'm going to do is a quick sketch. We've got now a line, and we've got a circle. So my circle here has a radius of 5 units, and the origin is at the centre. So if I just draw this up, it's going to look something like so. What we've also got is the line y is equal to x plus 1. So this point here is 0, 5. So y is equal to x plus 1 is going to look something like that. So what we've got then, that's a rough idea. We're going to have 2 points of intersection of these particular equations. So we're going to have one here, and we're going to have one here. If this was y is equal to x plus 10, then we wouldn't have any points of intersection, as we'd be up here. Okay, if it was x is equal to 6, for example, we wouldn't have any solutions. And when you went on to solve that, the quadratic, then you would get no real solutions. So how are we going to deal with this? Well, subtraction is not an option here, purely based on the fact that we've got an x squared and a y squared term. What I'm going to do instead is substitute equation 1 into 2. So what I'm going to do is 1 into 2. That's going to allow me to eliminate y. So if I think what I'm going to have, I've got x squared. I've got an expression for y, and that's x plus 1. So instead of y squared, I'm going to put now x plus 1 all squared, and that's equal to 25. So I've eliminated y by simply making a substitution. So substitution of equation 1 into equation 2. I now have a quadratic equation in x. So what I'm going to do is expand the brackets. So if I expand the brackets, I'm going to get x squared plus x, which is plus 2x, plus 1, and that is going to be equal to 25. So at this stage, just collecting like terms, 2x squared, I'm going to set the right hand side to 0, 2x squared plus 2x minus 24 is going to be equal to 0. So I'm just solving a quadratic here. I'm collecting on the left hand side ax squared plus bx plus c, and on the right hand side we're going to have 0. I can divide this equation by 2, so x squared plus x minus 12 is equal to 0. That's going to factor nicely, and we're going to have now x plus 4, and then we're going to have now x minus 3 is equal to 0. So we can see that x would be equal to negative 4, or x would be equal to positive 3. So let's put those on. Okay, so we now need to find our y values. Well, we know that y is equal to x plus 1, so I'm simply going to substitute them in. So we can say when x is equal to negative 4, we're going to have y is equal to, and this is just using now the first equation here, we're going to have negative 4 plus 1, and that would give us y is equal to negative 3. So this point right here is going to be negative 4 comma negative 3. So not a massively accurate sketch, but it gives us some idea. If we now look at when x is equal to positive 3, y is going to be equal to positive 3 plus 1, and that will give us that y is going to be equal to 4. So we've gone ahead and done that. So this one right here is going to be the point, and that will be the point 3 comma 4. So they are the solutions to our equations. If you're asked them in coordinate form, write them in coordinate form. If you're just asked to do them like so, you can do. Okay, so what happens now when you say, well, why did you do it in x? Well, we could have done it in y. So if I look at equation 1, what I could have said, I could have rewritten equation 1, and we could have said that y minus 1 is equal to x. We know what equation 2 is, so we could have simply substituted this in. So instead here, what we'd have, when I substituted 1 into 2, I would have now the following. I would have y minus 1 all squared plus y squared is equal to 25. That would allow me to solve a quadratic equation in y instead of x, get the points for y, substitute back in here to find x. So that's entirely up to you on how you want to do it. Okay, let's do another circle. Let's say we've got x squared. So x squared plus y squared is equal to 100. So this is a circle. It's got a centre at the origin and it's got a radius of 10. Let's take our linear equation and I'll write it now. Y is equal to 2x minus 3. So we'll call this one equation 1 and this one equation 2. All I'm going to do is eliminate y from equation 1 by making a substitution y is equal to 2x minus 3 into equation 1. So equation 1 becomes x squared plus, instead of y squared, our expression for y in terms of x is 2x minus 3, which we need to square, and that's equal to 100. So we need to expand the brackets. I'm going to get 4x squared minus 6x, which is minus 12x, and then we're going to have on here plus 9, and that will be equal to 100. We have a quadratic equation in x, and I can write this as 5x squared minus 12x, and then we're going to have now minus 91 is equal to 0. So this time we've got the quadratic equation. It looks a complete mess here, and we've got to deal with it. We could attempt to factorise this. I'm just going to use the quadratic equation. So let's say now that a is going to be 5, B is going to be negative 12 and C is going to be negative 91. So we know to solve a quadratic equation, x will be equal to negative b plus or minus the square root of b squared minus 4ac all over now 2 lots of a. So let's go ahead and find the x coordinates and then the y coordinates. So in the calculator what we're going to have is the following. We're going to have minus, so negative 12, so that's going to be positive 12, plus the square root of negative 12 squared, which is the same as 12 squared, minus 4 lots of a, which is 5, multiplied by c, which is negative 91, and that's all over 2 lots of a, which is going to be 10. So quadratic equation, which I'm assuming you're comfortable with if you're at this stage. If not, it's in the front of the formula book. Okay, so that's what we get. One of our solutions now, the positive solution, is 6 plus the square root of 491 over 5, which is an exact value. And then if I take the negative, we're going to end up now with the following. So if I do the negative, that's going to give us 6 minus, so we've got 6 minus. So let's just write these in. So we got 6 plus or minus the square root of 491 over 5. So let's take now, and we'll just go ahead and solve them. We'll take now the first one. So we'll say that x is going to be equal to the positive one of these, and let's write this down. So if we take the positive, we'll start with the positive, go from there. That's going to give me now 5, and I'll do these to 3 significant figures. We're going to have 5.63, so 5.63, and this now is to 3SF. What we're now going to do is find the y coordinate. So the y coordinate is going to be 2 lots of this, so 2 lots of a 5.63 dot dot dot, and I'm going to use the exact value, and then we're going to subtract away 3. So in the calculator now, all I've done is plug this into equation 2 to find the corresponding y coordinate. So what I'm going to do is 2 lots of my answer, and then I'm going to subtract 3, and that gives me now on here 8.26, and I'm going to round that to 3 significant figures. So I'm going to put that is going to be 8.26 again to 3 significant figures. So that's our first point of intersection. If I now take the next one, let's go ahead and do that. So the other one was the 6. So this is what we call an exact value. 6 minus the square root of 491 over 5. And that will give us the x coordinate, which is going to be negative 3.23. So x is going to be equal to negative 3.23. And let's just check that I've rounded that correctly. Yeah, and that's now to 3 significant figures. And therefore what we can say from here is that y is going to be equal to 2 lots of this answer that's in the calculator, dot 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 dot, and then we're going to subtract 3. So if I do that, I'm going to have now 2 lots of my answer, then I'm going to subtract 3 from it, and that's going to give me now negative 9.46. So let's go ahead and check that that looks good. So let's write this in. So negative 9.46, and that was to 3 significant figures. So let's just check I've rounded it correctly, and we can go from there. Yeah, there we go. So these are our values. So if you were to list them out, let's just put them on here. We'll have this one. So we've got 5.63 for the x coordinate and negative 3.23 for the other x coordinate. And then for the y coordinates, we've got 8.26, which is positive, and we have now negative 9.46. So however you list these is entirely up to you. Depends on how your exam board likes it. I prefer just to write them like so, but do check with your teacher. So that's an example when the numbers get a little messy. Let's just finish with one more. Let's say we've got now xy is equal to 6. And then we'll have now, let's go for x minus y is going to be equal to 5. Okay, let's just take a quick look at what's going on here. This might be beyond what you're expected to do, but it's interesting nonetheless. This could be rearranged to y is equal to 6 over x. So 1 over x looks something like this, and I'll just draw it. So 6 over x is not going to look a massive amount different. We're just going to have a scale factor stretch on it. So it'll look something like so. So remember, this is just a sketch. So this is going to be y is equal to 6 over x. If I rearrange this one, we could say now that this is going to be y is equal to x minus 5, which is a straight line. Now y is equal to x minus 5 is going to look something like this. Straight line, and it's going to have a gradient of 1 and a y-intercept now of -5. So we can see from here we're going to have 2 points of intersection. This isn't massively accurate, but just gives us some visual representation of what's going on. So how can we deal with this? So if we call this equation 1 and equation 2, we've got a couple of choices. What I'm going to do at this stage now is simply rearrange this into the form y is equal to x minus 5. So I'm going to write that equation 2, and just rewriting here, equation 2 can be written in the form y is equal to x minus 5. I'm now going to substitute that into equation 1. So what we're going to have is x multiplied by y. Well, that's now going to be x minus 5, and that will be equal to 6. So this is equation 1. I've now got a quadratic equation, and we can go ahead and look to solve this. So expanding the brackets, x squared minus 5x is equal to 6. So subtracting 6 from both sides, minus 6 will be equal to 0. So this looks like it's going to be x minus 6, and then we're going to have x plus 1 is equal to 0. So from here we can see that x is going to be equal to 6, or x is going to be equal to -1. So I've just gone ahead and solved. So I eliminated y this time by substitution to get a quadratic in x. From here, nice and straightforward, we're just going to use equation 2, and we're going to substitute this in and find the values of y. So we can say now, let's write this in, when x is equal to 6, y is going to be equal to 6 minus 5, so we can see that that is going to give us 1. So this is the point right here. So this will give us now 6, 1. If we now take x to be -1, so when x is equal to -1, y is going to be equal to -1, and then we're going to subtract 5, which gives us now -6. So this gives us now -1, -6, and that's what we have just there. So not a bad sketch, it's not massively accurate, but it gives us some idea of what's going on. This might be beyond the scope of your course, but I think it's interesting nonetheless, and we would use exactly the same technique. We're substituting to eliminate. So there we go, we've got quadratic equations, circles and reciprocal graphs with a linear equation. So you're solving when we've got one linear and one non-linear.